The key takeaways that I'd like this audience to get out of this call is really to know the power of entity centric detection. I think it's going to be very important that we understand what that means, which also means understanding the differentiated value that you can get from Sumo Logic for detection engineering and what that might mean. And ultimately, it's about helping you guys get prepared or be better prepared for the next wave of whatever comes at you in terms of modern threats. All right. So that's what I hope to deliver by the end of this session. Now, as Chaz and I were talking about, how do we go about doing this? We thought about lots and lots of different names for what this session could be about, right? Detection engineering, because firewalls need friends too, right? Or internal threats when good employees go bad. But we settled on hey, let's just keep it simple and talk about what does it mean to have detection rules around a particular entity and why that's important. So that's where some of this is coming from.
And I think to that point, like honestly, getting back to the foundational best practice of what is good detection engineering is critical. Um, it is hard, honestly, to find and alert on adversarial behavior. It is not an easy task. I spent a few years at the NSA on their red team, and the things that we would do to go, undetected is quite crazy, right? And the adversaries are obviously doing those same things. And you guys are at a disadvantage, right? Because they're looking for, one way in and you have to cover the entire, attack vector suite. And so hopefully Sumo Logic is really going to be a tool, in your tool bag or in your quiver to help you intelligently identify some of this behavior with as little friction as possible, right? Our tool is really designed to be user friendly once you understand the capabilities that it has. And we're going to peel back the curtains a little bit and help you guys really hopefully feel able to not be afraid, get in there, write some custom rules, understand the rules that we have out of the box. So yeah, it'll be a fun ride.
So the Real Housewives of Yuba, probably probably not the best title, but sure,
These are very creative.
And
right?
honestly, we've got a good number of participants on this call. I imagine some people didn't join because SIM is a painful topic, right? Oh, here we go again. It's historically had a bad rap, and that's the reality of it because, they're hard to use. And I thought this meme was funny, right? Because, you know, I probably lost a lot of my hair being a detection engineer in my former life. And not only is it hard to write the rules, but then you have the administrator say, hey, don't write a rule that's going to bring down the system, right? And then you say, okay, well, let's use a modern UEBA solution. It just opens up a whole nother set of problems. And so we're kind of trying to combat that um, bad reputation by doing things differently. And hopefully you guys see that. For those of you that are already deep in the weeds of detection authoring, you'll maybe be able to testify to that. So what does a modern sim do? Well, in our view, it should make writing these detections easier. And that means use some of the tried and true real-time rule correlation engine approaches that have been around since the advent of SIM, but introduce that new UEBA approach, but do it all, combine it all with an entity-centric approach. And that's what we're really talking about today.
And I think it's important to Chaz, as you bring this up, is as you're looking at security tools, and we thank you so much for looking at Sumo for this function within your organizations. We're going to really strive to say where we're different here. And one of the things that we're different at is having a rules engine that is customizable for you. It's transparent. You can see everything we're doing, and it comes with all the out of the box rules that cover basically 80% of the MITRE TTPs that are out there. So that's about saying, hey, we cover 80% of the things that we know about, and then now we're adding in the same rules engine with your same ability to customize, and we want to teach you how to do that, how to cover the other 20%, how to cover the things that we don't know about yet, and what's a good way to frame how to create those detections. And that's why we wanted to center around this idea of an entity or entity centric correlation and detections.
So I promise we're not going to go too heavy on slides, and I also have an environment pulled up that we can log into and kick the tires on. But I think it's worth underscoring the problem that a lot of security teams have today, right? And they've historically had, and that is just the sheer volume of alerts that are happening, right? You guys are adding tools to your security stack all the time. Every time the enterprise brings on a new security tool, what that means for you is yet another alert stream that you have to monitor. And, that's great. It's following, defense in depth practices, zero trust. All of these things are really great. But at the end of the day, your team is on the hook to respond and investigate every single alert that's firing. So you can go to the next slide. So we've got all of these different alert types. What do they have in common, right? And you can click through here. But there is a single data point that's common across all of these different alerts, and that actually is the entity. The entity is the glue that should be correlating across all of your different alerts. And once you start to change the way that you respond to or triage these alerts, it becomes much easier because I can take a single entity, cluster all of these alerts around that entity. What has user Bob been doing? Well, he's tripped a network alert, and he's tripped an OS alert, an EDR alert, a firewall alert, one of our, UBA rules tripped, right? And, I always visualize, whatever, pick your spy movie of choice, but they've got all the laser beams like protecting the crown jewels, right? As you're trying to break in and steal the crown jewels, you have to weave your way through all of these different tripwires. And that really is what all of these different security solutions are doing. But once you glue them all together, you can really start to paint a picture of what the adversary is trying to do. So layered on top of that, right? So first thing we got to do is cluster them around the entity. So check that box. Now what we need to do is start bringing in some additional intelligence. And Christopher mentioned already the MITRE attack techniques and tactics, right? Because now I can see, all right, what is the adversary doing as they're probing my environment, entering my environment, exfiltrating data, moving around laterally? You can start to add additional metadata to these different alerts. But again, you have to have that entity perspective from the outset, right? The entity might be the adversary, or the entity might be the victim, or it might be the host that's involved, right? Then you can do things like calculate the attacker dwell time. Historically, this has all been done by the tier one analyst. They have to come in here, okay, here's an isolated alert. Let me look before, let me look after, let me do the math to figure out how long this has been occurring. Let me see if there's any other events of interest that should be correlated. Now with Sumo Logic, right out of the gate, when we create what we call an actionable insight, all of that is essentially packaged up on a silver platter for you to start your investigation process.
What I like about this process, Chaz, is you can get a little bit predictive here. If via some of the MITRE tags for the signals that we're delivering for you from Sumo, you can say, "Hey, these tactics are being used. I'm in this stage, or I'm getting evidence of this stage of the attack. What's the next stage? What's the next stage after that? Now I have an ability to start looking for those activities, looking for those techniques, looking for the processes that the bad guy could be potentially using, because that's literally what we've seen in MITRE TTPs is this evolution of how these attacks happen.
Yeah, and honestly, one of the biggest challenges, I'm a big advocate for the MITRE attack framework. One of the biggest challenges has been how do you operationalize it? It's good to have all of this at a theoretical level, but now as a practitioner, how do you use that? And like you said, in Sumo, when you're writing a rule, we make it very easy for you to tag all of your detections with the tactics and techniques. They're all pre-populated. So you have a custom use case. Hey, I want to write a new, port sweep type rule. Well, I can do all of the logic with a couple clicks. I can attach these different, discovery type tactics to that rule itself so that downstream my analyst will know, okay, this was just early discovery. I don't need to pull the fire alarm yet. The severity is low. But when you correlate, well, they did discovery and then they did execution and then et cetera, now that attack timeline starts to be built out and you actually see the full story. And that honestly is worth its weight in gold as an analyst because now you can tell the story, right? And this is it. This is the silver platter that I'm talking about. I've got this particular insight. It's not a single alert. Now it's a cluster of alerts, all tied to the same entity, layered on with that rich metadata of MITRE tactics and techniques. All right, so now let's get a little bit into the weeds. Here we go, guys. So these are what we call the Sumo Logic rule primitives. And that's just, I think, a fancy word of saying rule types. One of the power that Sumo Logic brings is we have purpose-built rules to solve different use cases. So you're no longer in this world of I have to do everything as a crazy search with complex, subqueries and lookup tables and this and that. We've abstracted all of that complexity away and given you 6 different rules. And you can see on the screen here, if you read your examples under each one, pick the one that solves that particular need. Some of these are very intelligent rules that actually baseline against the entities. Specifically, my favorite rule types are the outlier and the first scene, right? Because, for example, you want to write a new rule that looks for certain behavior. Well, right out of the gate, when I create this rule, I'm going to have to start whitelisting. Okay, well, this is a power user. I should exclude this. This is my vulnerability scanner. I should exclude this. This team over here is doing some development. I'm going to have to whitelist them out. And it becomes this constant game of whack-a-mole, right? That's the old way. Now, all of a sudden, when you use these more intelligent rules, they're going to baseline every single entity against what they're observing the behavior through the logs, and then only notify you if it's the first time that it's seen or if there's some anomalous or outlier behavior, right? So you don't have to think about how that's done under the hood. And keep in mind, this is all done at cloud scale. Your enterprise might have 10,000 users. When you create a first scene rule, it actually is going to track 10,000 users independently. So the example there on first scene login from a geographic location. Every single user is going to be baselined. Where do they log in from? Well, their home ISP and their office. Now, if they log in from a location that's never been seen before, according to their entity profile, you're going to get an alert. So gone are the days of crazy whack-a-mole whitelisting and tuning. And Lisa, it looks like she just posted some documentation there. But that's kind of, so we're setting the stage here on choosing the right rule type. Make sure it matches the use case that you're trying to solve. You can go ahead and go to the next slide. Now, ultimately, remember when you're writing these rules, they're one small detection that's part of that larger kill chain or larger attack life cycle. Now, this is a contrived example, but it's actually fairly accurate to what you would see. And I want to walk through this a little bit, and then we'll actually go through kind of like a mock rule building exercise. But in this case, you'll see the value that each different rule primitive has in telling that story. So the first thing that you see, and this is basically a phishing um, breach example. So a user gets a phishing email. Now, typically, that happens all the time, and it's not something that you should be putting down your coffee for and spinning up a war room or anything like that because it's low fidelity, but you still need to track that. And so you can see here the very first thing that happens is a match rule. And a match rule could do nothing more than simply take in an existing security alert and convert that into what we call a security signal. So, hey, there's a phishing alert. This user got it. Every user that gets it is going to have a signal tied to their entity. Now, let's do some magic. Like, what is Sumo going to do added value? If that's it, if that's all I needed, you don't need Sumo Logic. But remember, Sumo Logic is monitoring all users in the enterprise. So maybe this is the first time this particular domain or URL address has been observed from your Proofpoint phishing security solution. That's interesting, right? It's not. This is a unique destination that hasn't been tried against your users before. It's going to pop a first seen rule globally. Well, what if that user clicked that email? They're like, oh, I got to log into my Bank of America account. Click. How are you going to know that? Well, that's where the chain rule comes in because it's able to correlate via the proxy logs, a totally different data stream. Hey, the same URL that he just visited happened to be in the phishing email that occurred 10 minutes ago. That's the power of having that chain rule. You couldn't solve that easily before because they're different data streams, right? Well, now let's continue on down this journey. That user is now starting to run Windows commands they've never been before. He happens to be an HR employee and he's not doing advanced Windows command shell, PowerShell commands, right? So that's interesting. Why is all of a sudden on Monday morning Bob running all of these advanced Windows commands? He's worked here for 10 years. He's never done this before. That's the power of the first seen rule. Moving on, now we have an outlier rule. There's a spike in traffic or some other resource that's never been done before. So as you can see here, we're trying to identify for you anything that's anomalous or unusual. Of course, you're going to have a threat match. You'll notice that could be later down the chain, like, okay, now they're communicating with command and control servers or whatnot, right? That's another thing. Then you'll get maybe well, there in red is the correlated insight, right? That's when Sumo Logic said, hey, stop what you're doing. I've got a series of signals clustered together. It looks like Bob's account might be compromised. Um, then you might get an EDR alert as well from his workstation. So every rule serves a different purpose. Get to know the rules, get to know how to write your own custom detections, and then keep in mind the end goal that each rule is not necessarily going to be analyzed or investigated or triaged in isolation. And so that's why when you create a rule, you could have a very low severity because you don't know necessarily what story is going to be told when you write that rule. Christopher, anything you want to add to that?
This is really important in understanding that each of these rules, as you just said, Chaz, could have their own severity and risk. So now you have levers that you can pull to raise the severity or risk level for one thing or another thing. If you're writing a rule, for your CEO, maybe that's a little bit higher risk in some cases and lower in other cases. But the benefit that Sumo's bringing to the table with our rules engine here again is you have that flexibility. Of course,
Awesome.
when I say
And
flexibility, I'm hearing in the back of my head, oh my God, now I have to deal with all this stuff. Well, no, because we've already taken, as Chaz says, a lot of the complexity out
Yeah,
of this process.
exactly. When you write these rules, um, you don't have to be conscious of, hey, I want to make sure this is all tracking Bob. You write the rule generically. All you have to do is tell it which entity field is important or relevant. In this case, username, right? That's it. Everything else happens automatically. To Christopher's point, maybe we'll do this is a 101 type webinar. Maybe we'll do a 201 webinar where you can actually overlay entity groups and you could have a VIP or executive group where every rule in this chain gets a multiplier. Hey, times the severity by 2 to push that risk profile faster, right? Because I definitely don't want my C-level executives to get owned. They're going to be a little bit more sensitive in the alerting, correlation, but we'll not go there on this call. But it's probably an interesting topic to maybe table for a next call.
Hey, I have a question. Yesterday in our company kickoff, when we had that customer share their experience with Sumo's Cloud SIM, and she had mentioned that Sumo's alert process started about 45 minutes to an hour before the EDR alert came in. Is this a sort of pathway, an example of how that may have looked like for them?
Yeah, that's exactly right. So we had an interesting customer, I guess they came on as to kind of give their testimonial as they moved from a legacy SIM into Sumo Logic. And one of the things that she mentioned was their team was now responding to alerts before their MDR provider or the EDR alert actually triggered. And the reason for that is we're able to do a lot of this correlation that happens before the actual workstation might be compromised, right? Or that foothold might be taken. And so, yeah, that's a great example, Lisa, of really, proof is in the pudding, real world, testimonial of that.
Mhm. Great. This is awesome. Thank you.
Yeah, and just to get a little bit technical on that, there's a lot of techniques and processes that are going on before the payload. So as you think about what is the adversary's goal here, let's say it's a ransomware, they want to check where all your important files are before they start encrypting them because they want to get you in an area that is more likely than not that you're going to pay to get your files back.
Yeah, it's scary, honestly, like not to throw too much fear around, but when you're using tools like ChatGPT, and I've tested this myself, um, you can specifically say, hey, I want to accomplish this thing on my Windows, system, but I want to only use Windows native commands, right? That living off the land approach. I don't want to trip any type of, you know, EDR solution that might be monitoring for custom payloads or binary malicious binaries. It will tell you exactly. It'll get into the nuances of, hey, launch PowerShell, use this Windows native command, and so the adversaries are getting very good at doing things that are difficult to track, right? Running malware in memory, things that they're not even touching the disk anymore. And that's why this layered approach, I think, is going to be even uh, more effective moving forward, right? Because ideally, not only do you have your EDR tool, which they're great, and you should definitely be leveraging them, but there are other attack vectors that you'll be able to track through the log stream or through point solutions, right? And the goal here really is to correlate those and identify patterns from the outset. All right, let's go move on. So this slide, excuse me, I included it because I think it's important. Um, when you guys start writing your detections, there's a lot of different approaches you can take. Historically, again, you could do it through search, and search is powerful. You can write some very advanced scheduled queries to find, security events of interest. However, as you can see here on the far left, it takes a lot of knowledge of the data streams what are the different Windows event IDs in this case? So this, by the way, this is a real world use case of brute force successful login. In other words, someone's banging on your front door, checking all your windows, and they finally figure out a way in, right? That's what we're trying to solve here. Um, in order to do this, write this detection against Windows events, you have to know, well, what is a Windows 4625? What is a Windows 4624? Which one is success? Which one is failure? What does Windows call the host? In this case, maybe it's computer, maybe it's system, where are the usernames? And Microsoft is notorious, by the way, for take one log and compare it to another log from the same Windows system, and they name everything completely different based on which Windows event ID is. And so good luck with that, right? If you love if you love memorizing hundreds and thousands of Windows event IDs and how things are named, maybe that's your gig. But moving to the right a little bit with Sumo Logic, remember every log message from the vendors is normalized. So and I go into a lot of customer environments and I say, hey, can I sit down and review some of your custom rules and searches? Let's see what you've built. And I'm surprised how often they don't realize that there's an entire data store of normalized records that they're not taking advantage of. So that same exact search on the left, written against the records index, which is post data normalization, right? That Sumo Logic data model um, becomes much more easier. Now I just say, hey, where normalized action is login and success equals true. How easy is that? Not only is it easier, it's going to be monitoring Okta logs and SailPoint logs and Windows logs and Linux and Mac and any authentication event, right? Because we're enriching and normalizing every log to a standard schema. That's huge. And now I can just do, hey, 10 failed logins followed by one successful login. That doesn't look good. They tried 10 times and now they're in. What's even better is moving into like picking one of our 6 rule primitives. Let's write this as a rule. Now, this particular chain rule, if 10 records match this, and look at the logic, it's 3 lines long. It cannot get any easier than this. Authentication, logon, success is true. 10 of those things, followed by 1 where success is false, at the very bottom in the exact order in 10 minutes. Anyone can write this rule, guys. Don't be afraid to get in. Now, am I saying you should never write a search against messages or a search against records? No. What I'm saying is pick the easiest path, whatever's most efficient. And, certainly rules are going to be a lot easier to manage. All right, hopefully that's useful. Now, again, this slide here is just showing you the options, right? You can write your detections on messages. If you write it against records, you're going to benefit from parsing, mapping, and enrichment. One common example that I like to share is anytime there's an IP address in a message, we will take that, run it through our enrichment process, and inject geo, city, state, lat, long, country code. So now all of a sudden, when I'm writing my detections on the record, if I want to use a bit of logic like, and this country code is not US or is China or whatever, I don't even have to do a lookup. It's in the record itself. Microsoft isn't going to necessarily tell me where an IP address is located, but in our records, data normalization and enrichment, we actually augment that, right? We make that part of the record itself. So there's so much value. Change the way that you're operating. Again, I see a lot of customers, they just don't, when I tell them this or I show them this, their eyes light up like, you mean this has been there the whole time and I haven't used it? Yes, that's exactly right. And again, all this data is going to the same security data lake. All right, so a little bit more in the weeds. Now, a common question I get is, when is an entity actually created and tracked in Sumo Logic? Well, two times, right? The first is anytime a rule generates a signal, if that entity doesn't already exist, it will create that entity. And again, your rule could be pretty generic. It could fire on 10,000 users. Now you're tracking 10,000 entities in your environment. The other time an entity is created is when you set up some sort of inventory. Inventory, by the way, is another area that I think is underutilized. Pulling in things like your Okta inventory, your Azure Active Directory inventory, your AWS inventory. Those are invaluable, right? Because it gets all of the user context, their OU information, their manager, their home offices, things like that. Set that up, and every 12 hours, that inventory collector or source will wake up, pull down everything that's in your identity solution, and then go back to sleep. 12 hours later, it'll wake up. And as it's doing that, it's actually creating entities in the Cloud SIEM to be tracked. Once those entities are tracked, we use that kind of risk modeling where anytime a signal is created, it's going to be tying that back to one of these entities. And it's going to be tracking them over some customized period of time. As that activity score, you guys can get in there and tweak that. As Christopher said, there's a lot of levers for you guys to pull to determine how many days do I want an individual to be tracked before it creates that insight. One other more advanced concept is, what if I write a bad rule? What if it's like just spitting out alerts? I don't want to blow up the triage and have my analyst, come kick the chair out from under me because I wrote a bad detection. Deduplication of signals is part of that signal clustering algorithm. In other words, Bob did this bad thing. He failed to log in 10 times over and over. Maybe he just has a bad memory. Maybe, he has fat fingers and he's just, mistyping it. Well, that's fine. We're going to automatically deduplicate those. And Bob is only going to get a single, hey, he's failing to log in at a high volume. All of those other signals will still be created, but they're going to be in what we call a suppressed state, right? They're not going to count against his risk profile. The only exception to that there you can see in parentheses is if you use dynamic templatized names in the signals themselves, then that duplication is kind of overridden, right? So and I'm debating whether I want to go into this more advanced topic, but let's say I extract out the timestamp. So Bob failed to log in, and hopefully we don't have a lot of Bobs listening to this because I'm picking on him a lot. But he failed to log in at 9:03 a.m. And if my signal name itself says failure to log in at 9:03, when he fails to log in again, it's going to be 9:04, and that's going to be the name of the signal, and it's not going to be grouped. It's not going to be deduplicated. Sometimes you don't want things deduplicated, sometimes you do, but just keep in mind that that's the way the system is designed to work. All right, next thing here. Again, I told you we're going to get a little bit deep, but another question that we commonly hear is, well, what is an entity? The first thing that comes to mind is it's a username. Robert. See, I'm going to use Robert now. But Robert, obviously, a username would be an entity, but so would an IP address. And a source IP and a destination IP, those should be tracked as independent entities. So what you see on the screen here are what we have out of the box. These are all the entities that we have out of the box. Hash values could be an entity. If you see something that's, you feel like should be an entity, but it's not listed here, all is not lost. You can create a custom entity type. So these are just the ones that were designed to track out of the box. Awesome. Lisa's backing this up with great documentation links. All right. So time check. I think we're doing okay here, guys. Hang with us. Now we're going to get into actually creating one of these intelligent rules that do the baselining. Now, again, as stated at the beginning, our goal is to help you guys feel comfortable writing some of these custom detections. They're not that complicated, honestly, when you break it down. The first thing that you're going to do is have your rule logic. And that is, you're looking at a lot of logs streaming into the Cloud SIM. Specifically, what logs do you want to look at, right? Things like the product and the vendor and the event ID or the action. That's the key here. Now, we're kind enough to give you a test rule expression so that you can actually write your rule and then click that button. It'll go back in time and say, hey, is this occurring, right? You want to make sure you test that before don't blindly trust it because maybe you're just one character off, right? Um, but that's that box here is the match expression. Then you have the fields. Now the fields is think of the fields as um, what are you aggregating against, right? And oftentimes it's just a single value, like maybe username here, or maybe it's actually probably more like the action that's occurring. Um, and then you have a choice. Do you want this particular rule to be globally baselined, mean across the entire enterprise? Or if you were to click that word global, it would allow you to select on an entity basis. That's often a point of confusion that I'll clear up here in just a minute. But then the last thing that you really have to worry about is which entity do you want to tie this activity to? And this is where you can say, throw the kitchen sink at it, honestly. Put in their username, host name, IP address, whatever, because when those signals are created, it will actually attach it to multiple entities, depending on, what's in the log itself. All right, so let's look at an example. This is a first scene rule for identifying Windows reconnaissance commands, right? So you have some commands that are not common, right? An adversary gets into the system, as Christopher mentioned, maybe they're going to start doing that early discovery. Well, I want to be notified if any of my users are doing this but have never done it before. That's the use case here. And that's why we're using a first scene rule. So the first thing that you're going to do is lower command line. So that means take everything in the command line field, which is part of our data model, our schema, put it in lowercase, and then start to enumerate those. So maybe they're doing a system info command. First thing that we would do on the red team is I got on a new system. I'm going to run this series of reconnaissance. What's my IP address? What's my system? What processes are running? Things like that. The next thing you need to do is determine, is this going to be a global or an entity? Most likely just choose global. They're easier to do. And then you're going to say, okay, what's my baseline field? Again, username is common. And the last thing I'm going to do is choose what entities in my, enterprise do I want to tie these alerts back to? In this case, I care about the host and I care about the username. That's it, right? So if you click to the next screen, you'll actually see one. This is it. Now it looks a little bit scary, mostly because I think this is one of our out of the box rules, but we took the time to list all of these reconnaissance commands for you. So what we're saying is if any these are all suspicious commands that I want to be monitoring for. Any of these are firing and that particular user has not been observed doing it before, pop an alert. Now, the great news is you would think like, oh, that's going to be noisy. No, it is not going to be noisy because remember, this is learning. It's going to take the time to learn over 7 days or 30 days and it'll quickly identify, well, these users are our power users or developers. They're always doing this. It's only going to alert you when that particular user has never done one of those commands before, right? Now, go ahead and click to the next slide. This is what's happening on the back end, making it super simple. All reconnaissance commands in your match list expression are being tracked. Anytime a user observed doing that thing, it's going to be added to this list. As it's being added to that list, it's creating an alert. Hey, Fred has never done one of these things before. Pop. Not necessarily that you want to say, okay, pull the fire alarm, Fred did something, but it's tying this signal back to his risk profile, his entity type. Now you can determine through the levers there, like how long do you want these, what's the TTL of this particular rule, and how long do you want it to learn? All of those are configurable, but we're not going to go into that. So that's it. Pretty simple, right? Now, question for anybody that's really sharp. What would happen if I add more fields to the baseline? In other words, not just the username. What if I added something else to the baseline? Well, it changes basically the table. So now all of a sudden I'm adding the actual command itself. So in this example, maybe system info is something that everybody does all the time for whatever reason. That's going to be part of the baseline. But now Bob logs in one day and for the first time he runs an NS lookup. That's going to be alerted. Hey, Bob and NS lookup is new. It's added to this table. It's not going to care about Bob plus system info anymore, right? So you can get very surgical with what's alerted on, right? Simply by tracking multiple different data points. Hopefully that makes sense, guys. You're not, in other words, instead of just adding the name, I'm adding what they're doing to that baseline. All right. Now, what if, okay, thus far we've just talked about um, global correlation, right? Now we're going to change, or what if I change this to an entity-based first scene rule? So same scenario, same use case. What does it mean on the back end? I'm choosing entity this time. Go ahead and click through. Under the hood, it's a little bit different. Now each user has their own table. So I'm not tracking the commands and correlating users. Now I'm tracking the users and all of the commands that they're running, right? It's a different approach. It almost solves the same use case, but through a different, different approach. So now Sally has done these 4 commands. Maybe she runs those every day. I will be alerted if Sally runs a command she's never run before, right? As will, and again, the cool thing about these rules is it scales. This is tracking thousands of users simultaneously, right? So yeah, I did. Hopefully that helps you guys. Now, what do we have out of the box? Luckily, we have a Sumo Logic Threat Labs team. This is all they do. So for the most part, you're not going to pull your hair out like thinking of these crazy use cases and detections. We do it for you. In fact, if you have a use case that we don't do out of the box, send it to our Threat Labs team. They'll queue it up. And what's cool is they'll release that rule globally to all Sumo users. And they do this twice a week. So and you're not even aware of it, likely. Every 2 weeks or so, they push out new rules. When we first released First Scene, it was like a dozen, then it went up to 30. Now it's at 69 today. And it grows and grows and grows, right? So that's the good thing. And don't try and, before you build a rule, check to see if we've already solved that use case, right? Go in and search our out-of-the-box rules, obviously. All right, I think we're doing pretty well on time, Christopher. Cool doing just a little thought experiment here. So what if a customer, or you are the customer, but your customer is perhaps, your application owners, and they're like, hey, I want to be alerted anytime new communication happens between 2 systems on an internal IP address, this port 1337. Well, you can think a minute like, okay, how would I do this? Hopefully by now you're going to rule out, I'm not going to write a scheduled search against the network logs, right? The messages, that's going to be hard, right? Cisco and Palo and AWS and all of these firewall vendors, they have logs in different formats. Don't go there. Then maybe you're going to think, well, maybe I use the records index. You could do it that way too. Hopefully you don't do that. You say, you know what? They've got this thing called a first scene rule that is designed specifically for identifying new behaviors. Let me try that. So the very first thing that should pop into your head is product and vendor. Okay, I know it's vendor Amazon. In this case, where are network logs captured? In the VPC flow logs. We're starting to build out our match conditions. Now we're going to say, okay, focus on the destination port that was provided to me. Now I'm going to say source IP is internal. How does that work? Remember, we talked about the enrichment that happens at the record creation time. An IP address is going to be labeled as internal. Source IP is internal, device IP or destination IP is internal. All you have to do is call it out is true. We're going to go with a global first scene rule here. Now, this is the key part that many people would probably miss. On my baseline field, I want to call out the source device IP and the destination IP. Why? Because I'm trying to pair them together, right? Any traffic over port 1337, not just from this source, not just to this destination, but from a particular source to a particular source, right? That's the grouping that we're going after. And then, of course, what I'm going to create a signal. How do I tie that back to an entity? Choose your entity, which would probably be host name. And you could throw in username as well. You can know like who's logging in and doing this behavior. That's it. So hopefully that was a good little exercise. Now, quick FAQ here. How do I tune UEBA rules? Well, be careful when you tune them because um, if you modify the match list expression, it's going to actually reset the baseline, which may be a good thing, right? Maybe our rule is too noisy and you're going to get in there and tweak it a little bit. Just remember, if you tune that expression, it's going to wipe out the 30 days that it's been learning all this time. Instead, try using a tuning expression, right? And if you're really advanced, you're going to use a match list. Oh, it says matchy list. I kind of like that. Misspelling there. Um, but yeah, so use tuning expressions, take advantage of those. Can you reset the baseline? Well, as I just described, any change that you make to the logic of the rule is going to reset the baseline. It's making the assumption of, oh, you're changing the behavior of what I'm watching for. It's going to clear those tables out that we showed and reset. Again, it's probably a good thing. Can I view the baseline data? No, you cannot view the baseline data. However, we do expose, like when you write an outlier rule, when those signals fire, you are presented with kind of that timeline of like where the spikes and the valleys are. Um, would you ever set a baseline to 0? Yes, you would. The reason for that would be if I were to log into a system and come up with a brand new first scene rule and write it today, I have to wait 7 days for that rule to actually fire. Why? Because it has to learn. It has to learn all my users, has to learn what's normal for those users. Um, if I want that rule to fire from day one, I'm going to set that to a 0 so I can track, okay, these rules are firing properly. The good news about that is it's adding those behavioral actions to the profiles of those users. It's learning, in other words, but you're still getting the signals. Now, it's almost like a prototyping thing. Now you can slide that baseline back up to 30 or 7 or whatever. It's not going to reset the baseline because that's not a change in logic. It's just a change in the time to live. Um, I will tell you, I think I can safely say this. This is a roadmap item, but I think this quarter we're releasing historical baselining, which I'm super pumped about. A lot of customers have asked us for this. Essentially, when I create a new rule, a new UEBA rule, we've got all the data. It's going to go back in time, chew through all the data, and make those baselines so that we'll start firing anomalies from day one. So that's
I was
coming.
about to say that, Chaz, so I can semi-confirm. But if you're a customer on this call and you want to get more information about that, we can have a separate roadmap conversation.
Yeah.